In this lesson, we're going to keep building our dynamic line marking materials by adding dashed lines between our road lanes. Just like we did with the center line, we'll use named attributes and some basic Boolean math. Let's think about what we need to do. We already have the center line stored as an attribute. Now we want to mark all the other lines, the ones that are not shoulders and not the center, as dashed. These lines separate the lanes. If the line is not a shoulder and not the center, then it should be a dashed line. But we also need to handle a special case. If there are only two lanes, we still want that center line to be dashed. So we'll need to add a check for that too. First, let's figure out how to identify the shoulder lines. That part is easy. When we created the curves earlier, the inside and outside curves were used as shoulders. So we can mark them using a named attribute. Set the attribute type to Boolean and call it shoulder. We know the inside shoulder is already isolated. For the outside one, we can check if the duplicate index is 0. If it is, we know that curve is also a shoulder. Let's duplicate our store attribute node and use it to mark these as well. This helps us avoid confusion later when adding logic. To check our work, let's use a named attribute node and view the shoulder and a center. Attributes in the spreadsheet. Make sure your view mode is set to spline so you can see the attributes clearly. You should now see which lines are marked as shoulders and which one is the center. Now we need to find all the lines that are neither. Use a Boolean math node with the NOR operation. This gives us true only when both inputs are false. In this case, if a line is not a shoulder and not the center, it will be selected. That's perfect for our dashed lines. But remember, we also want to support two line roads. In that case, we still want the center line to become dashed. So let's add another condition. Use a math node to check if the number of lines is greater than 2. Then use another Boolean math node set to, and to combine this with the earlier result. This way, dashed lines only appear if both conditions are true. That gives us a good selection for the dashed markings. Once that's ready, store it as a new named attribute called dash. Set the type to Boolean and confirm it's working correctly. Now let's bring this dashed info into our shader. To make the lines appear dashed, we're going to use a simple shader trick. We'll mix a solid material with a transparent one. The mask that controls this will tell the shader where the line is visible and where it should be transparent. First, we need to UV unwrap the line meshes. Fortunately, we've already done this before for the pavers, and the same method works here. We'll store a 2D vector named attribute for the UV. Set the domain to face corner and use a combine XYZ node to control the values. Use a capture attribute node on both the main curve and the profile curve. For each, we'll capture the spline parameter. Plug the results into the X and Y inputs of the combine XYZ node. Don't forget, because the line markings are closed loops cyclical, we'll have a problem unless we convert them to spirals. We already have a group node called curve to spiral for this. Drop that over the cyclical parts of the geometry. Now go to the shader editor. Add a texture coordinates node and view the UV map we just created. You'll probably see some strange stretching, especially if the UV are scaled too large. To clean it up, we'll separate the X and Y values and use the X-axis as a gradient. This gradient will help us make the dashed pattern. Add a math node and set it to a modulo. This will repeat the gradient at regular intervals. Think of it like wrapping numbers. If you set it to 4, the gradient will restart every 4 meters. It's perfect for repeating patterns like dashed lines. After the modulo node, add a less than math node. This gives us a sharp on-off switch between each segment of the dashed pattern. For example, if you set the threshold to 1, the line will be visible for 1 unit and invisible for the rest. You can also add a node before this to offset the pattern if needed. Now we can use this result as a mask to mix 2 shaders, a transparent one and a standard principled BSDF. Connect the transparent shader to one input, the principled to the other, and use the mask as the factor. This gives you dashed line materials. But right now, all the lines are dashed. We only want dashed lines on the separators, not the center or shoulders. So we'll use the dash, named attribute, to fix that. Duplicate the mix shader. Then plug the principled shader into the second input. Add another attribute node and set its name to dash. Connect this attribute to the mix factor. Now the dashed effect only appears on lines marked with the dash attribute. You can flip the mix inputs with Alt+S if needed. Now you should see that only the separator lines are dashed. Center lines are solid yellow, and shoulders are solid white. This setup is fully procedural. If you reduce the number of lanes to 2, the center line becomes dashed and yellow automatically. You can even control the dash size and spacing from the shader. To make this even easier, we'll group these shader nodes. Select all the dash logic nodes and press Ctrl+G to turn them into a group. Add 3 inputs to control the offset, dash spacing, and dash size. Label the inputs clearly so it's easy to understand later. You can set their subtypes to a distance if you want better control in the UI. Name the group line dashes to keep it organized and hidden from the regular menu. This gives us a flexible shader node that we can use for any dashed lines in our scene. Now we can offset, scale, or tweak the pattern without changing the geometry. In the final part of this chapter, we'll complete the line markings by adding double lines to the center.